As with any vehicle, a tractor-trailer is made up of many parts. Though these parts have individual jobs or functions, they work together to effectively and efficiently operate the tractor-trailer. Having a general understanding of the basics of vehicle construction and vehicle systems, as well as the importance of diagnosing and reporting vehicle malfunctions, will help you maintain a safe vehicle. The frame is the structure around which the vehicle is assembled. It is the vehicle's foundation. The frame includes left and right side frame rails and cross members connecting the frame rails. This provides strength and support to the frame. The frame is connected directly or indirectly to all parts of the truck. The engine is secured to the frame by engine mounts. Axles and wheels are connected to the suspension system through the frame. Some types of vehicles, including many cargo tanks and van trailers, do not have a frame. In this case, the exterior of the vehicle carries the vehicle's weight. As you review this course, keep in mind that vehicle construction varies and that the parts covered may not be included on all vehicles. The suspension system supports the body and frame of the truck. It is made up of springs, airbags, torque arms, and mounting brackets or hangers. The front and rear axles are attached to the suspension system and the frame rests on it. The suspension system allows the axles to move up and down in response to ground changes without seriously affecting the load. Securing the suspension system at points spread throughout the frame allows the stress of road shocks to be distributed evenly throughout the frame. The strength and durability of the system is determined by the size and weight of the vehicle, as well as the size and weight of the cargo being hauled. During your pre-trip inspection, ensure the suspension is intact, tight, and in good working order. There are two main types of suspension systems: leaf spring and airbag suspension systems. In some cases, both leaf spring and air ride suspension systems are combined to provide the best of both systems. Leaf spring suspension systems use metal strips of different lengths that are connected and attached to the spring mounts or hangers. In general, the axles connect the wheels to the rest of the vehicle and help support the weight of the vehicle and its cargo. Individual axles perform specific functions. The front tractor axle is the steering axle. It connects the steering mechanism and brakes. Rear tractor axles are the power or drive axles. They transfer power from the engine and drivetrain to the wheels and serve as the connecting point for the brakes. Axles fall into two types or categories: dead axles and live axles. Dead axles do not transmit power. They are used to support the load. Live axles transmit power from the drive shaft to the wheels through a differential gear housing. The live axles contain the necessary components to transmit power to the wheels. The engine supplies the vehicle's power. Engines are primarily fueled by diesel or gasoline, but some modern trucks use propane and natural gas as well. The engine on a truck tractor is an internal combustion engine. This means the engine burns fuel with enclosed chambers inside the engine. The enclosed chambers are called cylinders. It is within the cylinders where the power comes from to operate the vehicle. The engine's parts include engine block, cylinders, valves and injectors, pistons, connecting rods, and crankshaft. The diesel engine has a series of fuel injectors. Fuel and air are mixed during compression. The compression in a diesel engine is much higher, and the heat created by the compression pressure causes ignition of the fuel-air mixture. Gas engines have fuel injectors and spark plugs, or in the case of some older vehicles, a carburetor and spark plugs. A serious engine defect could result in a breakdown or accident. When inspecting the engine compartment, make sure you check all fluid levels: oil, coolant, power steering, transmission, if applicable. All hoses for leaks, wear, or looseness. All belts for wear or looseness. The alternator, water pump, and air compressor. The engine compartment for leaks, and the electrical wiring insulation for cracks or wear. The fuel system provides fuel for engine operation. It controls the amount of fuel sent to the engine and determines when the fuel is injected into the cylinders. The fuel pump draws fuel from the fuel tanks through the fuel lines and fuel filters to the fuel injectors. The fuel injectors are operated by an injector pump and spray a fine mist of fuel into the engine cylinders. Cleanliness is very important when it comes to the fuel system. Even the smallest amount of dirt or debris can damage the engine. A properly operating fuel system will eliminate many impurities, but it is also important that you use great care when fueling your vehicle. The fuel tank is where the fuel is held. There may be 1 or 2 fuel tanks depending on the size and type of vehicle. Additional tanks may carry fuel for heaters and reefers. A series of filters clean the fuel throughout the fuel system. These filters remove dirt, water, and rust from the fuel system. Fuel system heaters are especially important for vehicles operated in cold weather. In general, there are 3 types of heaters: in-tank units, which heat fuel in the tank, inline units, which heat fuel when it is going from the tank to the injector system, and filter heaters, which help heat the fuel as it passes through the fuel filter. Some diesel trucks do not have fuel heaters. In very large engines, some of the fuel that goes through the engine is not actually burned, but is returned to the fuel tanks by way of a fuel return line. This process of the fuel returning to the tank heats the fuel, and some companies count on this as their fuel heating system. Fresh air is important in the operation of an engine. The air intake and exhaust system are responsible for assuring that the engine processes enough fresh air to function properly. The air intake system filters out dust, dirt, and water, and delivers a large amount of fresh air to the cylinders. After combustion, the exhaust system collects the used gases, passes them through the turbocharger, and then expels them through a tailpipe or exhaust stack. The turbocharger converts the power it gets from the exhaust gases into power that can be used to force more air into the engine. The aftercooler cools the intake air from the turbocharger to a temperature that can be used by the engine. The pyrometer is an instrument that measures the temperature of exhaust gases. The normal temperature is between 600 degrees Fahrenheit and 1000 degrees Fahrenheit, depending on the vehicle. If the exhaust temperature is too high, the engine and the turbocharger can be damaged. During your pre-trip inspection, make sure the exhaust is in good shape. There should be no cracks or excess soot buildup. The lubrication system has 3 purposes. It lubricates the engine. The lubrication system delivers clean oil to parts of the engine. This allows the engine parts to move without rubbing together, friction. This increases engine efficiency and prevents damage. It cools the engine. The moving parts of the engine create a great deal of heat. Oil flowing through the engine absorbs some of this heat and removes it from the engine, keeping the engine temperature at a safe level. It cleans the engine. Oil helps keep the engine clean. As it travels through the engine, it picks up dirt and other particles that can damage the engine. These particles are filtered out of the engine. Oil also prevents rust and corrosion by coating surfaces that do not move within the engine. Proper preventative maintenance can go a long way in making sure your vehicle's engine operates efficiently and effectively. It is important that the oil is changed on a regular basis according to the vehicle's manufacturer's recommendations. As part of the oil change, the condition of the oil filter should be assessed. The oil filter is where the dirt and other contaminants that the oil removes from the engine are deposited. A clean oil filter allows clean oil to flow through the engine more freely. It is also important to check the oil level in the engine on a daily basis. This can be done by using the dipstick. The dipstick is found at the side of the engine. Though heat is important to engine operation, too much heat can damage an engine. The cooling system lowers the heat level of an operating engine. Coolant, a combination of water and antifreeze, is stored in the radiator and circulated through engine water jackets by the water pump. At this point, the coolant is collecting some of the engine's heat and then returns to the radiator. In the radiator, the heated coolant travels through tubes which cool the coolant. The cooled coolant then recirculates, repeating the process. Always follow the engine manufacturer's requirements for selecting coolant. Make sure the radiator is filled with the proper amount of coolant. Too much or too little coolant can damage the engine. The climate the vehicle will be operating in will determine the level of coolant antifreeze protection necessary. It is not uncommon for vehicles that operate in extreme northern climates to use coolant that will not freeze until the temperature reaches 40 degrees below 0 Fahrenheit. If you are going to check your coolant when stopped during a trip, wait a few moments after stopping. Then be careful when removing the radiator cap, as the engine may be hot, and you could be splashed or sprayed with hot engine coolant. The electrical system serves many purposes. It is used to crank or start the engine and operate the vehicle's electrical equipment, including lights and instruments. The electrical system is comprised of 4 parts: circuits, charging, cranking, ignition, and lighting and accessory. The cranking circuit moves electricity from the battery to a starter motor. Depressing the starter switch inside the vehicle gets this process started. The ignition circuit is the electrical circuit that provides sparks for each cylinder, igniting the fuel and air mixture in a gasoline engine. An ignition circuit is not needed in a diesel engine. The lighting and accessory circuits provide electricity for the vehicle's lights, horn, instrument lights, and windshield wipers. This system takes electrical power from the battery and/or charging system, depending on demand and engine power status, and routes it through an overload protection system, fuses or circuit breakers, to operate electric systems and accessories. Should a wire be overloaded due to an excessive power demand being placed upon it, or become worn or damaged and come into contact with a metal portion of the vehicle, called a short or short circuit, this will cause the overload protection device to stop the flow of power to the wire. To resume flow, the cause of the overload or short must be addressed, and the overload protection device replaced, if using fuses, or reset, if using breakers. The location of the fuse or brake box varies from vehicle to vehicle. Some vehicles have reset breakers, which attempt to reestablish the circuit automatically when tripped. However, if the cause of the overload or short is not addressed, the reset breaker will continue to kick out every time it tries to reestablish power to the circuit. The drivetrain is a series of connected mechanical parts which take the power generated by the engine and applies it to the tractor's drive wheels. The drive wheels are normally the rearmost axle or axles. However, in some cases, all axles on the vehicle may be receiving engine power, such as in the case of a 4x4 or 6x6 tractor. When expressing which wheels receive engine power, the first number is how many axle ends or wheels the vehicle has. The second is how many of those axle ends can receive engine power. Most tractors have either a 3-axle 6x4 configuration, 6 axle ends with the rear 4 being the drive wheels, or a 2-axle 4x2 configuration, 4 axle ends, the rear 2 of which receive engine power. The drivetrain is comprised of the clutch, transmission, drive shaft, universal joints, and differential. These parts modify the engine torque, the rotational force generated by the engine's crankshaft, into power that can be used to move the vehicle down the road. A serious defect in any of these parts could cause a breakdown or accident. The clutch is the part of the powertrain that allows the driver to connect or disconnect the engine from the powertrain. The clutch allows the driver to stop without stalling the engine and shift gears. The clutch is comprised of 7 major parts: clutch housing, flywheel, clutch discs, pressure plate, release assembly, clutch brake, and controls, clutch pedal and linkage. In most trucks, the clutch has 3 main components. One plate is squeezed tightly between 2 other plates. The plate in the middle is the driven member, clutch disc, which is connected to the shaft leading to the transmission. The other 2 plates are driving members which are connected directly to the engine. A strong spring or springs force the 2 driving members together. This tightens their grip on the middle plate until they all turn as one unit. The engine flywheel is used for the first driving member. It has a smooth surface where the pressure plate pushes up against it. The other driving member is called the pressure plate. It is a heavy steel ring which is smooth on one side. It is fastened to the cover, which is bolted to the flywheel, so they all turn together. It is fastened so it can slide back and forth when the clutch pedal is pushed and released. The clutch disc, or clutch plate, is a flat disc of steel with friction facing on each side. The plate is fastened by splines to a shaft going to the transmission. It fits into grooves on the transmission input shaft, so the clutch disc and the transmission input shaft turn together. When the pressure plate moves forward, the clutch pedal is released, the clutch disc is trapped between the flywheel and the pressure plate, allowing the engine power to turn the transmission input shaft. When the clutch pedal is pushed, the pressure plate is pulled away from the flywheel and clutch disc, allowing the clutch disc to freewheel. When this happens, the engine power is not being sent into the transmission. To stop the clutch plate from spinning free and put the transmission into gear when stopped, the driver must push the pedal all the way to the floor and activate the clutch brake. The clutch brake uses friction to stop the clutch plate and transmission input shaft from freewheeling, allowing the driver to put the truck into gear without having to grind or force the gears together. To avoid damaging the clutch brake, the clutch should only be depressed halfway, just far enough to get the clutch to disengage when the vehicle is moving. The only time it should be pushed all the way to the floor is when the vehicle is stopped and the driver needs to put the vehicle into gear. The transmission is basically a box case of various sized gears. It is located behind the clutch and is fastened to the clutch housing. The transmission adjusts the power generated by the engine. This provides the correct speed and torque needed. It transmits this power from the engine to the drive or powered axles in order to propel the vehicle. The transmission's gears control the speed of the vehicle. Though the engine only operates at a certain RPM range, the gears allow the vehicle to move at different speeds. Another property of the transmission is torque. This is what makes something rotate. The torque of the gears in a transmission is related to the amount of power a vehicle exhibits. The gears let the driver vary the force, torque, that the engine delivers to the wheels. By manipulating the gears in the transmission, you can change the ratio between the engine and the rear wheels to produce more speed or torque as needed. When inspecting the vehicle, check the transmission for leaks or other damage. Behind the transmission is a propeller which runs to the rear of the vehicle. This is called the drive shaft. The drive shaft is a hollow shaft that connects the transmission to the rear of the vehicle. At the front and rear of the shaft are universal joints. They are, in most cases, made up of two U-shaped pieces at right angles to each other and fastened together by a cross having arms of equal length. The drive shaft transfers the twisting motion of the engine to the rear axle. The universal joints connect the shaft to the transmission and the rear axle. The U-shaped pieces pivot on the arms of the cross. Since there are two pivots, the two shafts can be at an angle to one another and still turn around and transmit power. They do not have to be in a straight line. This is important because they become somewhat misaligned with each bump in the road. The rear axle moves up and down with the wheels, while the transmission moves very little as it is fastened to the frame. The universal joints allow the drive shaft to keep on turning smoothly even though its two ends are not always directly in line with each other. A drive shaft is normally made up of two shafts, with a spline connecting the two halves. The spline area allows the drive shaft to become shorter or longer as the vehicle's drive axles move up and down when going over bumps. The differential is the part of the drivetrain that transfers the driveline power from the drive shaft to the wheels, and it splits the drive axle in half, allowing one wheel to turn at a different rate of speed than another. This helps a vehicle when turning. When performing a turn, the outside wheel must rotate faster than the inside wheel, so your right wheel is actually turning at a different speed than your left wheel. When inspecting the vehicle, check the differential for excessive wear. The brake system is what slows down and stops a vehicle. It is made up of three major elements: service, emergency, and parking brakes. Service brakes slow down and stop the vehicle. The service brakes are regulated by the driver by using the foot treadle and trolley valves. There are two types of service brakes: drum and disc. Drum brakes. This metal cylinder looks like a drum that is bolted to each end of an axle. The braking mechanism is located inside the drum. To stop, the brake shoes and linings are pushed against the inside of the drum. This causes friction, which slows the vehicle and creates heat. When too much heat is created, the brake drum softens and stretches, resulting in the loss of braking power, making it harder and, in some cases, impossible to stop. Disc brake systems have a fixed disc attached to the inside of the wheel, which rotates with the wheel. To stop, the pads and linings are squeezed against the side of the disc, which creates friction to stop the vehicle. Emergency brakes slow down and stop the vehicle when there is a failure in the air system. The red 8-sided button on the dash controls the emergency brakes on the trailer. The tractor parking brake system doubles as the tractor's emergency brakes and are controlled by the yellow diamond-shaped button. Parking brakes prevent vehicle movement when parked. The yellow diamond-shaped button on the dash controls the parking brakes. The emergency and parking brakes in air brake-equipped vehicles use spring brake chambers. These chambers will not allow the brake to release if there is not enough pressure in the brake system and will cause the brakes to apply if pressure to them is lost, such as the driver applies the parking brake, which drains the air out of them, or falls too low, such as due to a leak. The following steps outline the process of a basic air brake system. The pressurized air is pumped by the compressor to the wet tank where moisture is removed. The air then passes through the one-way check valve to the dry tanks. When you put your foot on the brake, air flows through the service lines to apply the brakes by putting air into the service brake chambers. At the same time, air flows through the tractor protection valve and through the trailer service glad hand to apply the trailer service brakes. The air from the foot valve directly fills the brake chambers on the front axle. However, on the drive and trailer axles, the air from the foot valve causes the relay valves to open, indirectly putting air into these service brake chambers. And when you release the brake pedal, air escapes through the quick release valves on the foot valve, tractor relay valve, and trailer relay valve. The purpose of the anti-lock system, or ABS, is to control wheel lockup, which can cause a vehicle to skid and possibly jackknife. This is accomplished by an electronic system which senses the speed of each wheel. When the wheel speed sensor detects an imminent lockup, a valve is opened and air in the chamber is released. As the wheel speed increases, the valve is closed and air is reapplied. Most ABS-equipped vehicles have ABS malfunction warning lights. Tractors are normally equipped with a warning light for the tractor ABS and one for the trailer ABS. Trailers are normally equipped with a yellow light at the driver's side rear corner. These lights should turn on for a few seconds when starting your vehicle. If the light stays on or suddenly turns on while you are driving, the ABS may not be working. Though you still have properly working brakes, the anti-lock function may not be working. Get this checked out as soon as possible. A defect in the braking system can interfere with a vehicle's ability to slow and/or stop your vehicle. A wheel is a round object with a hub that is connected to the axle. The axles connect the wheels to the rest of the vehicle and help support the weight of the vehicle and its cargo. The tire is affixed to the wheel. The tire is the rubber that grips the road, allowing the vehicle to move. There are two types of wheels found on most trucks. Spoke wheels are made up of two pieces. One piece is the spokes. The spokes are attached to the hub. The second piece is the rim. Spoke wheels are heavier and more difficult to align and balance. Disc wheels are made of aluminum or steel. They are easier to align because they are fastened to the hub using lug studs that are on the hub and lug holes in the rim, much like a car wheel. There are two types of wheel mounting systems used on most trucks. Stud-piloted mounting systems use the studs on the wheel hub to guide and center the wheel. Hub-piloted mounting systems use the wheel hub to guide and center the wheel. The wheels are fastened by either ball seat nuts or flange nuts. There are 3 types of tires used on most trucks. Radial tires. The body ply cords on radial tires run around the tire perpendicular to the tread. Radial tires also have belt plies that run circumferentially around the tire under the tread. This type of tire construction allows for better traction and fuel mileage. The tread on radial tires lasts 40 to 100% longer than other types of tires because when the surface area of radials comes in contact with the road, they have greater traction while creating less friction and less heat. This gives your vehicle greater fuel mileage and better performance. Bias ply tires. The body ply cords on bias ply tires run diagonal across the tire. The tire may also have breakers or narrow plies under the tread. While bias ply tires wear faster than radial tires and reduce the vehicle's fuel mileage, they are a tougher tire and are used in special applications where tire damage or wear from severe service are a concern. Belted bias tires. The body ply cords on belted bias tires run diagonal across the tread, and belted plies run circumferentially around the tire under the tread. The belts on this tire are of heavier construction. Generally, radial and bias ply tires should not be mixed. All tires on your vehicle should be the same size and type. The differences in traction and turning capabilities among the different types of tires can cause problems if the types of tires are improperly mixed. There are ways to properly mix the tires. Consult the tire manufacturer for guidelines instructions. Some tires have tubes that fit between the tire and the rim. The air that keeps the tire inflated is kept in the tire tube. Flat tires are more prone to tire fires because the underinflated tube spins inside the tire, creating excessive heat. Tubeless tires are mounted onto a single-piece wheel. The tire, instead of a tube, holds the air. Tubeless tires are lighter, easier to mount, and the most common. Proper tire inflation is important. Underinflation can increase tread wear and reduce the life of the tires. Overinflation can damage the tires and reduce stopping efficiency. Consult the vehicle's owner's manual for inflation guidance. Tire pressure should be checked regularly. This should be done with an accurate gauge when the tire is cool. If the tire is hot, the pressure reading will be higher. If you do check a heated tire and the pressure is higher than recommended, do not release any air. Wait until the tire is cool and check again. There are 2 basic truck tire tread designs. Rib tread. The tread grooves on these tires run parallel with the tread bead. This type of tread is recommended for the front wheel positions on tractors. Lug tread. In over-the-road high-torque service, lug treads provide maximum protection from wear and greater traction. Generally, these tires will last longer when installed in the drive positions when compared to rib tread tires. Proper tire inflation has many benefits, including increased fuel efficiency, a smoother ride, and a reduced chance of blowout or tire fire. Inspect your tires often and check the pressure with a tire gauge. Refer to the manufacturer's specifications for correct pressure. When inflating a tire, keep in mind the maximum pressure for the load you are carrying, making sure you do not exceed the rim or wheel rating. During regular operation of your vehicle, the pressure of the tires should increase as the tires get warmer. Expect increases of 10 to 15 psi. Greater increases, which can create an abnormal amount of heat, may indicate underinflation, excessive speed, and/or incorrect tire size. If this happens, you should stop, investigate, and correct the problem. When a tire is underinflated, the following can happen. The tread wears down more quickly. The temperature within the tire increases, possibly causing the separation of the tread from the body or belt ply. And deflation can occur, weakening the tire's body cords, potentially causing a blowout. If you operate duals and one is underinflated or flat, a fire can start. This occurs because the flat tire flexes into the other tire and/or the remaining tire is carrying the load intended for two tires. An overinflated tire becomes rigid, making it easier for the tire to be cut or punctured by objects on the road. Overinflation also makes the ride less smooth, as the tires are unable to absorb shock. Tires should be rotated periodically based on manufacturer recommendations. This will help in evenly distributing wear. If two tires of differing diameters are positioned together, the larger tire will begin to overheat and bulge out at the sides due to taking on more of the load. The smaller tire will wear irregularly because it doesn't have proper contact with the road, possibly causing the tread to separate. If the larger tire bulges too far, it will begin to touch the other tire, increasing friction and heat between the two, which can cause a blowout in one or both of the tires. To be on the safe side, allow no more than 1/4 of an inch difference between the diameters, no matter what the tire size. Also, keep the spacing between the tires at the recommended distance to prevent the tires from touching, creating a heat buildup. The following alignment characteristics are built into the axle by the manufacturer. They may be changed as necessary. The caster of an axle is the amount of tilt it has. This is measured in degrees, and it is recommended that the axle have positive caster. It tilts forward. When set this way, the vehicle will want to naturally move straight ahead and will recover from turns more easily. Positive caster makes it easier for you to steer. The camber of the wheels is the degree of tilt they have with respect to the road. It is best when the truck's wheels have a positive camber to support the load. In other words, the distance across the top of the wheels is greater than the distance across the bottom. When a heavy load is placed on the truck, it straightens out the tires with the road. Other alignment characteristics are the result of wear and damage. The most notable of these include toe in. The wheels on the same axle are closer on the front than the back. And toe out. The wheels on the same axle are closer in the back than the front. Power steering allows you greater control of your vehicle. There are many advantages to power steering. It takes less effort, reduces driver fatigue, road shocks are better absorbed, and easier to maneuver the vehicle in difficult situations. The coupling system is what connects the tractor and trailer. Two main components make up the coupling system: the fifth wheel and kingpin. Landing gear supports the front end load weight of the trailer when uncoupled. Landing gear is usually cranked up or down. Landing gear has either wheels or skid feet attached to the bottom. The fifth wheel is a coupling device located on the tractor's rear frame. It is used to couple, the front end of the trailer to the tractor. The fifth wheel is a flat, rounded plate with a V-shaped notch in the rear. The kingpin, which is located on the trailer, fits into the fifth wheel, allowing the tractor to pull the trailer. There are several types of fifth wheels, including fixed mount and sliding adjustable. The fixed mount fifth wheel is secured in a fixed position behind the cab and has three parts: the base plate, bracket subassemblies, and frame mounting members. The base plate includes the locking mechanism. It also takes on the majority of the stress of coupling. The bracket subassemblies keep the base plate in place. And the frame mounting members are structural steel angles bolted to the fifth wheel. The sliding or adjustable fifth wheel slides backward and forward to accommodate different types of loads. The sliding fifth wheel may be locked into place with pins that fit into holes in the slider track, or by a plunger that fits into a row of slotted holes. Adjustment of a sliding fifth wheel may be done by hand or by a control in the cab. When adjusted by hand, the driver manually moves the pins or plunger and adjusts the fifth wheel by moving the tractor forward or backward. When adjusted from the cab, activating a switch unlocks the locking device. The driver then sets the trailer brakes and moves the tractor forward and backward until the fifth wheel is in the correct position. Proper maintenance of the fifth wheel is important. Check the fifth wheel for cracks, breaks, and security. Make sure the fifth wheel has the right amount of grease so it functions properly. Missing U-bolts, cracked or broken welds, or other defects in fifth wheel mounting devices should be repaired or replaced. The kingpin is attached to the upper fifth wheel plate under the front of the trailer. It is a 2-inch steel pin that attaches to the fifth wheel to couple the tractor to the trailer. Check the kingpin for excessive cracks, bending, or wear. You should be aware of your vehicle's condition at all times. Your ability to spot a potential problem can help in diagnosing a vehicle malfunction. As well as being alert for warning lights and alarms, pay attention to your senses. Sights, sounds, smells, and/or the feel of the vehicle can indicate a potential problem. Report to your company anything that doesn't seem quite right and have it checked out. Sight. Look at your vehicle's gauges. Know what the proper readings are and what readings indicate a potential problem. Watch for defects in all vehicle components when performing vehicle inspections. Sound. Listen for unusual or abnormal equipment sounds. Squeaks, squeals, thumps, and rattles can be the first sign of vehicle malfunction. Smell. Be aware of unusual smells, including burning rubber, hot oil, or fuel. Feel. Be aware of vibration, swaying, or other movement that isn't normal for your vehicle. In many cases, a vehicle will give you clues that there could be a problem. Some things to watch for that may signal a possible problem include inconsistent, erratic gauge readings, unusual sounds, rattling, whining, grinding, or a sharp drop in fuel mileage. If you notice a problem, stop your vehicle as soon as practical. If you can, try to identify the source of the problem. If the problem is one you can fix based on your knowledge, experience, and company policy, do so. If you cannot fix it, report it to your company. Make sure you include a description of what you observed and how the vehicle acted, responded. Get mechanical help as soon as possible. You should now be able to explain the function of major combination vehicle systems. Check all key vehicle systems to ensure their safe operation. And identify what is needed to keep vehicle systems in good operating condition. Now it's time to take the course exam. This exam includes 10 questions. Be aware if you close the exam before finishing, your answers will not be saved. You may take this exam more than once. Your highest score will be reported. To begin the course exam, select Next.